Good evening, my dear Senior 2 students. Our lesson today in statics is equilibrium, the second part, which is meeting lines of action of three equilibrium forces. The first rule, if a rigid body is in equilibrium under the action of three coplanar non-parallel forces, then the lines of action of these forces meet at a point. For example, if you look in the figure in front of you, there exists a uniform rod AB. Its weight is W, is in equilibrium on a smooth vertical wall and on a rough horizontal ground. Then the weight of the rod acts vertically downwards from its midpoint, which is mean center of gravity of the rod. Number 2, reaction R1 is the reaction of the smooth wall acts vertically, which is mean this reaction is perpendicular to the wall and will be intersected the extension of the weight at point D. Number 3, reaction R2, which is mean the reaction of the rough ground with unknown direction, and to determine its direction will be passed through point of intersection of R1 and W at the previous rule. Example number 1, a metallic sphere of weight 2 kg weight and of radius length 30 cm is suspended at point B on its surface by a string of length 30 cm. Its other end A is fixed at a point in a vertical wall to be in equilibrium as it rests on the wall. Find the magnitude of the tension in the string and the magnitude of the reaction of the wall. We shall draw the figure. This is the metallic sphere. Its weight from its center acts vertically downwards, 2 kg weight, rests on the vertical wall. So there exists a reaction going out from the point of resting, which is C, is perpendicular to the wall itself, which is R. The sphere is suspended from point B by a string. The other end of it is fixed at the wall, so there exists a tension here. The string AB of length equal the radius length of the sphere, so this is 30, this is 60. So the side CM is half the length of the hypotenuse. So the angle opposite to it, which is angle A, equal 30. So angle AMC equals 60. So angle beside angle 60 will be 120, and here is 90 and 90. So by applying Lam's rule, 2 over sine angle between R and T, which is mean 120, equals T over angle between R and 2, which is mean sine 90, equals R reaction over sine of angle between T and weight, which is mean 60 and 90, which is mean 150. By using crossing multiplication, you will find that T equal 4 root 3 over 3 kg weight and R equal 2 root 3 over 3 kg weight. Example number 2. AB is a uniform rod of length 60 cm. Its weight 24 kg weight acting at the midpoint of the rod AB. The end A of the rod is attached to a hinge fixed at the vertical wall. We shall draw the figure step by step. First, AB is uniform. This is AB. As he said at the end of the question, it's horizontally. Uniform means that the weight going out from its midpoint D acts vertically downwards. This rod, the end A, is attached to a hinge in the vertical wall, so there exists a reaction from the hinge. We don't know its direction, and the other end of the rod, which is mean B, is fixed by a string. This light string means has no weight. Its other end of the string is fixed at point C on the wall, vertically above A by 80 cm. So there exists here tension. We extended the weight to intersect the tension, so the reaction from the hinge passed through this point, which is mean M. So the three forces intersected here at. We noted that the triangle MCA, its sides parallel to the line of action of the forces and taking in the same cyclic order. So this triangle is the triangle of forces. We have here length of AC equal 80. AB equals 60. By using Pythagoras theorem, you will find that BC equals root 60 squared plus 80 squared. It will be 100. and M is midpoint of CP, so CM equal 50 and MB equal 50. AM is a median, and this median going out from the right vertex, so it will be half the length of the hypotenuse, which is mean that AM equals 50 centimeters. So after applying the triangular forces rule, T will be over MC, or will be over AM, and the weight 24 over CA. So T over 50, R over 50 also, and 24 over 8. So T and R are equal because they have the same denominator. So T equal R equals 15 kilogram weight. Exercise number 3. AB is uniform rod of length 140, weight 480 gram weight. Its end A is attached to a hinge fixed on a vertical wall. A force F acts horizontally. So from here we know that the rod is not horizontal, so I will draw it inclined. The rod here AB, inclined rod, of length 140. Its weight acts from its midpoint T, 480 acts vertically downwards, so the length of AD equal DB equals 70. Its end A attached to a hinge, so that there exists a reaction, we don't know its direction. Force B acts horizontally from B to make the rod at rest, which is mean equilibrium, at position in which the rod inclined to the horizontal by angle of measure 30. Find the magnitude of F, reaction and direction of the reaction at the hinge A. Magnitude and direction of the reaction at the hinge A. So we extended the force F to intersect the weight at point M. So the reaction from E, its extension should pass through M. So the triangle ACM is a triangle of forces, its sides taking the same cyclic order and parallel to the line of actions of the three forces. We have here D midpoint of AB, M also midpoint BC, so DM equal half AC, and AC equal 70 because it's opposite to angle 30 in 30-60 triangle, so DM equal 35. We have CP using Pythagoras theorem, root 130 140 power 2 minus 70 power 2, it will be 70 root 3. So CM will be 35 root 3. Okay, we have CM 35 root 3, we have AC equal 70, so the length of MA using Pythagoras theorem will be 35 root 7. Applying triangular forces rule, F over CM, R over MA, and 480 over AC. So F equal 240 root 3 gram weight and R equal 240 root 7 gram weight. And he needs now direction of the reaction. We will get the measure of angle AMC. Tan AMC equal AC over CM, which is mean AC 70, CM 35 root 3. So measure of angle AMC after making tan minus 1, the answer will be 49 degrees 6 minutes, which is mean that the reaction of the hinge makes angle of measure 49.6 with the horizon. Example number 4. Uniform rod of length 50 cm and weight 120 gram weight, suspended at its two ends freely by two strings. Their other two ends are fixed at one point. If the length of the two strings are 30 cm and 40 cm respectively, find the magnitude of the tension in each of the two strings. So we shall draw the figure, and we noted that the uniform rod here is not horizontal, which means inclined, and attached by two strings, T1 and T2 as in front of you, intersect at point C. Their length is 30 and 40. And he said that the length of the rod is 50. So this is converse of Pythagoras theorem. So we have the angle ACB equal 90. And we call the two angles in front of you theta and alpha. We noted that CD is a median going out from the right vertex, equal half the length of the hypotenuse, so CD equal 25. Which is mean that the triangle ADC is isosceles, and the triangle CDB also isosceles, which is mean theta, and here alpha and alpha. So we have here Sine theta and sine alpha now becomes easy. Applying the Lem's rule, T1 over sine alpha, T2 over sine theta, and 120 over sine 90. Sine alpha equals opposite 30 over hypotenuse 50. Sine theta equal opposite 40 over hypotenuse 50. Using crossing multiplication, we have T1 equal 72 gram weight, T2 equal 96 gram weight. Example number 5. Uniform rod rests with its two ends on two smooth planes inclined to the horizontal at angle of measure 60 and 30. So the rod here is inclined. This is the two smooth planes, one of them inclined by 60 and the other by 30. AB is the uniform rod. Its weight acts from its midpoint M vertically downwards 24, and we noted that the two planes are perpendicular. He said find measure of the angle which the rod makes with the horizontal at equilibrium position. So he needs angle YAB, and also he wants also the value of the two reactions R1 and R2, if you know that the weight is 24. We have here AY and XD are parallel, so angle XDA equals angle YAD equals 60 alternating angles. And you know that DM is a median going out from the right vertex equals half the length of the hypotenuse, which is mean that DM equal MA and equal MB. So the triangle AMD is an isosceles triangle, which is mean that angle MAD equal angle MDA equal 30. So the needed angles YAB equal 60 minus 30, it will be 30. Applying Lem's rule, R1 over sine 30, R2 over sine 60, and the weight 24 over sine 90. So the reaction 1 equal 12 Newton and R2 equal 12 root 3 Newton. AB is a uniform ladder of weight 8 through 3 kg weight. Its upper end A rests on a smooth vertical wall and lower end B rests on a rough horizontal ground. This means that the ladder is inclined. Here the ladder AB, its end A rests on a smooth vertical wall, so the reaction going out perpendicular to the wall R1. Its weight from its midpoint, because it's uniform, 8 root 3. We extended the weight to intersect the reaction at E. And the reaction from the rough horizontal ground should pass through their point of intersection E. So the two reactions R1 and R2 are unknowns. If we noted that the triangle EDB, its sides parallel to the line of actions of the three forces and taking in the same cyclic order. So this triangle is called triangle of forces. To find its lengths, we have we have that the length of AC root 3 meter, as he said, and the rod itself AB, its length the unknown. You have point B is far from the wall by 2 meters, 1 and 1. So you can have the length of ED equals the length of AC equal root 3 meter, DB equal 1. So AB using Pythagoras theorem will be 2. Applying the triangle of forces rule, R1 over dB, which is 1, R2 over BE, which is 2, 8 root 3 over ED, which is root 3. So here R1 equal 8 kg weight and R2 equal 16 kg weight. Next example number 7. AB is the uniform rod of length 120 cm and weight 15 kg weight. Its end A is attached to a hang fixed at a point on a vertical wall. The rod is kept in equilibrium horizontally. So we draw the rod horizontal AB. Its weight 120, its length is 120, and its weight 15 kg weight, and it's uniform from its midpoint. Attach A at the hang, its reaction unknown direction. The rod kept equilibrium horizontally by attaching it at point C, where C belonged to AB, where AC equal 80 centimeters. So C after the midpoint by 20 centimeters. The other end from C of the string is fixed at point D. This is above A directly by distance 80√3 centimeters. Calculate the magnitude of each of the tension in the string and the reaction of the hinge. The triangle EDA, its sides parallel to the line of actions of the forces and taking in the same cyclic order. So this triangle is called triangle of forces. You have only AD equal 80√3. We have here this side MC 20 centimeters and AM equal 60. We know that the triangle CEM and triangle CDE are similar because EM and DE are parallel. So CM over CA equal CE over CD equal ME over AD. And from this relation, we can get the length of EC. I draw it again. We can get the length of CE, which is mean CE equals 40 centimeter. So DE 160 minus 40 equals 120. 120 DE and AD equal 80√3. We can have the length of AE by using Pythagoras theorem will be 40√3. Then we shall apply the triangle of forces rule. 15 over DE, R over AE, T over ED. So R over 40√3, T over 120, 15 over 80√3. So R equals 7.5 kilogram weight. T equals 15√3 over 2 kilogram weight. Example number 8. A string of length 24 centimeter fixed from its ends at 2 points A and B in a horizontal line. The distance between them is 12 centimeter. The string passes inside a smooth ring to be suspended in it. Its weight is 144 dyne. Then the ring is pulled horizontally by a force, which is mean that the string AB is not horizontal. Here is the 2 points A and B, and the string here consists of 2 parts, as here. Distance between A and B is 12, and the length of the string is 24. So we suppose that MB equal L, and ME will be 24 minus L. By applying Pythagoras theorem in the triangle ABM, we have that the length of L equal 9. So our measure of angle MAB, we call it theta, alternating, so this angle also theta. The force here is horizontal, and there exists a weight 144 dyne. So sine theta from here equals BM over AM, which is mean sine theta equals 9 over 15, which is mean 3 over 5, and cosine theta equals 12 over 15, which is mean 4 over 5. But we have here 4 forces, T and 144, and F and T. So we will use the idea of the previous lesson, lesson number 3, concurrent forces. Because here we have the rod is in the string is in equilibrium, so the sum of forces that around x-axis equals 0 and also around y-axis equals 0. So x equal F cosine 0, T cosine 90, T cosine 180 minus theta, 144 cosine 270 equals 0. So from here cosine 90 equals 0, so this part is cancelled. Here negative cosine theta, and we have cosine theta equals 4 over 5. Cosine 270 equals 0 cancel. So the relation from here, F minus 4 over 5 T equals 0, and we call it number 1. Number 2, y equals 0. So F sine 0 plus T sine 90 plus T sine 180 minus theta plus 144 sine 270 equals 0. Sine 0 equals 0 cancelled. Sine 90 equals 1, so it will be T. 180 minus, this is second quadrant, the sign positive, and 180 doesn't change the sign. So it will be T sine theta, which is mean 3 over 5T. Sine 270 is -1. So you have from here t equal 80 dyne. Substituting in equation number 1, you will have the value of f, it will be 64 dyne. Good luck in the next time.